All right, today we're going to tackle something that pretty much every single programmer does, all day, every day, working with text. But what if I told you there's a hidden performance trap that could be lurking in your code right this second? Well, stick around because we're going to uncover it and show you the really simple way to fix it. So let me just ask you this straight up. Is your code secretly slow? It's a real question, because one of the most common, most innocent-looking things you do in your code might be costing you way more performance than you could ever imagine. And here it is. This is the scene of the crime right here. You're inside a loop. Maybe you're processing a big list of items. Maybe you're building out a long report, and you're just adding bits of text together, piece by piece. It looks so simple, right? It works. But what's really happening under the hood? Let's break this down, and we're going to start with the usual suspect.
And that suspect is, of course, the standard string. It's the first tool we all reach for when we need to handle text. It feels simple, it's reliable, but it has this one core characteristic that's both a huge strength and, in our little loop scenario, a major weakness.
And that characteristic is something called immutability. Now, this is a really crucial concept to get. Immutable literally means that once a string object is created in memory, its value can never, ever be changed. So just think about that for a second. What does that imply when you want to change it?
You know, the best way I've found to think about this is to imagine a string is like a printed, laminated document. It's final. It's sealed in plastic. If you spot a typo or need to add just one more word to the end, you can't just take out a pen and write on it, right? No way. You have to go back, create an entirely new document from scratch, and then print and laminate that new version.
Okay, so what does this mean when you write a super simple line of code like this one? You're just adding hello world onto hello. It looks like you're just editing the original string, but because of immutability, that is not at all what's happening in your computer's memory. So here's the big reveal of what's really going on. The system takes hello, takes world, and creates a completely new, separate string object for hello world. The original hello string, it just gets tossed in the trash, marked for garbage collection. Now, imagine doing that inside a loop 1,000 times. You've just created and then immediately discarded 1,000 useless objects. That's a ton of waste.
So if the string is the problem here, then what's the solution? Well, let's meet the hero of our story. A tool that was built specifically for this exact job, the String Builder.
Okay, if a string is that laminated document, a string builder is like a whiteboard. It's designed for change. You can write on it, you can erase a little bit, you can add more text over here, and you're doing it all on the same board. You don't have to get a brand new whiteboard every single time you want to make a tiny little edit. Now the code looks just a little bit different, but the goal is exactly the same. We start with hello, but instead of that plus equals sign, we use a method called append. And this tiny change in syntax, well, it leads to a massive, and I mean massive, change in efficiency. And this right here is the magic. This is the key difference. When you use append, the original string builder object in memory, or whiteboard, is simply modified in place. That's it. No new object gets created, no memory gets wasted. The text is just added on to the end. It is incredibly, wonderfully efficient. All right, we've met our two contenders. Now it's time to put them head-to-head in a direct showdown so we can really see the difference and just nail down everything we've learned.
You look at this code side by side and you're thinking, what's the big deal? It's a simple choice, right? Plus equals versus dot append. But as we've just seen, the consequences of that choice, especially when it's happening over and over inside a loop, are just worlds apart.
Okay, this table pretty much sums up the whole thing. On one side, you've got string. It's immutable. It cannot change. That makes it slower if you have lots of changes. It's best for simple, fixed text. On the other side, you've got string builder. It's mutable. It can be changed. This makes it way faster for lots of modifications, which makes it the absolute perfect tool for building text in loops. So look, this isn't about one of these being good and the other being bad. That's not the point. It's all about being a smart developer, you know? Understanding your tools and choosing the right one for the job so you can write code that's not just clean, but also really efficient. So let's boil this all down to a super simple checklist for you. Just use a normal string for any text that's not going to change much, for simple, small values. But the second you find yourself building or modifying text inside any kind of loop, you switch to a string builder. It is such a small change to your code, but it can make a gigantic difference in your app's performance.
And that really brings me to a final thought here. Knowing the difference between String and StringBuilder is a fantastic, easy optimization win. But it really makes you wonder, doesn't it? What other seemingly simple, everyday choices that you make in your code could be having a huge, hidden impact on its performance? Definitely something to think about.